Okay, let's run the demo. To run this demo, we need to install nvSRAM motion tracker software, which will appear into all program file once it is installed on your PC. Open the application program. You will see that it appears with two windows. Window on the left hand side indicate couple of graphs, which is displayed as XYZ, and this XYZ component is a reading of sensor output for its X, Y, and Z direction, and left hand side column is XYZ component of gyroscope or compass or accelerometer output, which is read out in the real time from the demo hardware or from the PC when I'm replaying the demo. Right hand side column shows XYZ component of gyrometer or accelerometer or compass when it is read out from the NV log, which is nothing but stored into nvSRAM memory during the runtime data logging, and being replotted on these three graphs. So we have provided options to display whether it's a gyrometer, accelerometer or compass reading. So default is a gyrometer. User can select to display accelerometer or compass output on these graphs. There is a second window which is a display window, and it shows Kately as an object, and this object is used to replicate the box in the software, and since it is an open source file, we have used this Katly as an object and to replicate the demo cube and to show the movement of demo by movement of the Katly. So to start this, we need to first position switch towards USB, and once it is positioned, I need to connect mini USB cable, and I will connect to the USB port onto the demo. So as soon as I connect, I will see that one green color LED turns on, indicating that demo is getting power via USB port. And to check whether demo hardware is synced with the PC or not, you can see the status on the bottom of this application software, which indicates connected, and which is a sign of hardware getting synced with the PC and ready for the communication. Now we will select the get data option. So as soon as I select get data option, I can see that XYZ graph are being plotted, and since there is no movement to the on the object, XYZ components are static, and there is because the gyrometer will send out static data. Now let's start moving. As you see now, that object is also turning according to the cube position. Now I am moving cube in a different direction, and I am tracking the each and every movement of the cube and sending it out to the PC, and PC internally convert that moment and moving the Katly as an object accordingly. This moment is also being recorded into nvSRAM in the runtime, and all this moment will be replayed by reading out from the nvSRAM. Once I will say stop. So I will say stop. Now I have stopped communication with the hardware. First I will run a replay of the demo, and the replay is nothing but this data, which is XYZ plot, which is nothing but a gyro output, is being stored into a PC file. So to replay that, I need to go to the file option, select open, and then select inventions_data file, load it, then select checkbox from PC and click on get data option. Now data is being read out from the PC and being plotted on XYZ axis. Basically is nothing but it's actual XYZ component of a meter output, which was recorded during object movement, and now being replotted. Now I'm going to read out content of nvSRAM, which also holds a copy of this moment. So for this I need to uncheck from PC option and get nvlog. Now this time right hand side XYZ graph shows XYZ component of gyrometer output, and this is stored into nvSRAM, and it's now being read out through the USB port. Now I will compare the data uh, between data which is read out from the PC or in the real time, which is displayed on the left hand side column graphs, and right hand side column XYZ component, which is the data read out from nvSRAM, and you can see that these two data are identical for its X, Y and Z component, indicating that data which is stored into a PC also have a file or identical information is stored into nvSRAM in the real time, and this demonstrates that nvSRAM is capable of capturing data in real time and capable of storing it and securing it. So now I will move this demo to other PC. So I will remove the USB connection from one PC. Now I will connect to the other PC where I am already opened up application software. I will connect USB cable. Now as you can see, now status shows as a connected. In this case I will just read out data from nvSRAM memory. So I will click get nvlog, and nvSRAM data is being read out via USB port onto different PC now. Since data is recorded and stored into nvSRAM, both data remains identical, and it will be saved even when there was no power available to the board, which indicates nvSRAM non-volatility. So as you can see that right hand side column indicates the same pattern on XYZ axis, which was there on this PC. Even though I transferred hardware, basically I transferred the connection of hardware from the PC, from one PC to another PC. So this indicates that nvSRAM is capable of successfully hold the data when there is no power, and also demonstrated that nvSRAM is capable of logging real-time data and storing it when there is no power. So this demonstrates nvSRAM data logging capability in real-time application. Thank you.